morning, Dr. Sneha and everyone. Thank you for tuning into our presentations today. Since this is a recorded video, I hope you find it informative. And before we start the presentations, I would like to introduce myself. My name is BCT and I'm a leader of Group 6 with the topics of energy productions in solar panels. And in the presentations, I will discuss the environmental, social and health impacts of energy productions in solar panels. Now I would like to invite my teammates to introduce themselves.
Hey guys, good morning. My name is Marlisa binti Amal, metric number 241141882, and I will be discussing the introduction and application of energy production in solar panels in this presentation.
Good morning, my name is Nok Jun Kit. I will be discussing incorporation of circular economy, challenge and limitation of energy production in solar panel in the presentation.
Good morning, my name is Muhammad Azrul bin Abdul Barir, my number metric 241141883. I will discussing about the opportunity for further improvement in solar panel and conclusion.
Thank you everyone. Let's start our presentation.
Introduction of energy production in solar panels. Solar panels are devices that convert sunlight into electrical energy. They are made up of many photovoltaic PV cells, which are typically constructed from semiconductor materials like silicon. When sunlight hits these cells, it excites electron generating direct current electricity. This electricity can then be converted into alternating current using an inverter for use in homes, businesses, or the electrical grid. Solar panels are a key component of solar energy systems and are widely used in renewable and sustainable energy production. They are commonly installed on rooftop, in open fields like solar farm, or integrated into other structures. Importance of solar panels. Solar panels are vital in addressing environmental challenges and improving energy efficiency. They are significantly reduce greenhouse gas emission by generating electricity without burning fossil fuels, which helps combat climate change and improve air quality. Solar energy decreases dependence on non-renewable resources like coal and natural gas, supporting a shift to sustainable energy practices. By directly converting sunlight into electricity, solar panels enhance energy efficiency and offer long-term cost saving for homeowners, businesses, and industries. Additionally, they improve public health by eliminating air and water pollution associated with traditional energy production. Solar energy are also scalable and adaptable, making renewable energy accessible for both small-scale residential use and large-scale utility projects. Technological innovations such as high-efficiency panels and energy storage integration have further improved by performance and affordability. Moreover, solar energy creates economic opportunities by generating green jobs and fostering energy independence. Overall, solar panels play a crucial role in reducing environmental impacts, enhancing energy security, and building a sustainable future. Application of energy production in solar panels. Solar panels have a wide range of application across residential, commercial, agricultural, and industrial sectors, making them a versatile and essential renewable energy source. In residential settings, solar panels are commonly installed on rooftop to power homes, reduce energy bills, and lower carbon footprints. Homeowners also use off-grid solar system in remote areas where access to the grid is limited. Solar water heaters powered by solar panels provide an eco-friendly way to meet household heating needs, while battery storage system ensure a reliable power supply during the night or cloudy days. In urban area, community solar projects allow multiple households to share energy from a single solar array, promoting inclusivity in renewable energy adoption. In the commercial and industrial sector, businesses and factories install solar panels to offset operational energy costs and meet sustainability goals. Warehouses, corporate offices, and shopping malls utilize rooftop or ground-mounted solar systems to generate electricity for lighting, HVA system, and machinery. Large-scale solar farm, which consists thousands of interconnected panels, contribute to utility-scale power generation, supplying renewable energy to entire communities and reducing reliance on fossil fuels. This installation often use solar tracking system to maximize energy production by following the sun's movement throughout the day. In agriculture, solar panels are revolutionizing traditional farming practices by powering water pumps for irrigation, providing electricity for cool storage of crops, and enabling solar dryer to process grains and fruit efficiently. Solar-powered greenhouse help farmers regulate temperatures and extend growing season. Agrivoltaics, a practice that combines solar power with crop cultivation, optimize land use by generating energy while protecting crops from extreme weather conditions. Environmental challenges of solar panels. Despite their numerous benefits, solar panels present certain environmental challenges that need to be addressed for their widespread adoption to remain sustainable. The manufacturing process of solar panels is energy intensive and relies on raw materials like silicon, silver, and rare earth metals. Extracting and processing these materials can result in habitat destruction, water pollution, and carbon emissions. Additionally, the production of solar panels requires chemicals and energy which contribute to their initial carbon footprint, although this is offset over time through clean energy production. The significant challenge is the disposal and recycling of solar panels at the end of their 25 to 30 years lifespan. Without proper recycling infrastructure, discarded panels contribute to electronic waste, which may include hazardous materials like lead or cadmium that pose environmental and health risks. Furthermore, large-scale solar farms can require significant amount of land, potentially disrupting ecosystems and competing with other land use such as agriculture and conservation. While solar panels are a cleaner alternative to fossil fuels, these challenges highlight the need of sustainable manufacturing practices, improved recycling technologies, and thoughtful land use planning. Addressing this issue is critical to maximizing the environmental benefits of solar energy and ensuring it remains a sustainable solution for global energy needs. Global producer and location of solar panels. The production of solar panels is dominated by a few key countries like China, leading as the largest global producer, accounting for over 70% of the world's output. Chinese companies such as Long-I Green Energy, Jinko Solar, Trina Solar, and GA Solar among the top manufacturers known for their large-scale production and cost-efficient technologies. The United States also plays a significant role, focusing on innovation and high-quality solar technology. Companies like First Solar, specializing in thin film panels, and SunPower, known for high-efficiency modules, represent the U.S. solar industry. Europe countries like Germany, Norway, and Spain are notable producers, with companies such as REC Group and SolarWorld focusing on sustainable manufacturing practices. India is rapidly emerging as a solar manufacturing hub, with leading companies like Adani Solar and Vikram Solar scaling production to meet both domestic and international demand. Meanwhile, South Korea and Japan are known for advanced solar technology, with companies like LG Electronics and Panasonic producing high-performance panels. Emerging production hubs in Vietnam, Malaysia, and Thailand have also gained prominence as Chinese manufacturers diversify operations to these regions. This global production center collectively drive the growth and adoption of solar panels, supporting transition to renewable energy worldwide while focusing on efficiency, innovation, and sustainability. Importance of solar panels. Solar panels are vital in addressing environmental challenges and improving energy efficiency. They are significantly reduce greenhouse gas emissions by generating electricity without burning fossil fuels, which helps combat climate change and improve air quality. Solar energy decreases dependence on renewable resources like coal and natural gas, supporting a shift to sustainable energy practices. By directly converting sunlight into electricity, solar panels enhance energy efficiency and offer long-term cost saving for homeowners, businesses, and industries.
Now let's talk about the environmental impacts of energy productions in solar panels. Firstly, the lower carbon footprints. Because in the energy productions of solar panels, the life cycle carbon footprint of photovoltaic system range from 20 to 50 grams of carbon dioxide per kilowatt hour, and compared to coal power emits approximately 820 grams, and natural gas emits around 490 grams carbon dioxide per kilowatt hour. In the manufacturing phase of solar panels, it will emit gases due to the energy-intensive processes, requirement to extract and process raw materials. And besides that, in the energy productions of solar panels, it requires high energy requirements. Energy usage of solar panels involved in manufacturing, operations, and end-life process. In manufacturing, the energy is used in material extractions, processing, silicon purifications, and water productions, and module assembly. At the end of the life processes, the energy is used in dismantling, transporting, and recycling. Additionally, it generates greenhouse gas emissions. The greenhouse gas emissions primarily during the energy-intensive process, which are extractions and processing of raw materials, manufacturing of components, and module assembly. The largest emissions contributions is due to the manufacturing of batteries, which consists of 54% of total emissions. And furthermore, it's generated waste. Waste is generated during manufacturing in the industrial process. With the increasing growth in the development and utilizations of solar energy resources, the waste solar panels will increase. The waste such as harmful waste, materials, and gases such as poly, raw magnetite, flame retardants, heavy metals, and chlorofluorocarbons. It requires significant amounts of water. Water is primarily used for cooling, cleaning, and chemical processing in the productions of solar panels. Water is required for cooling purposes, steam generations, infrastructure manufacture. And furthermore, various products of solar panels has minimized the environmental impacts. Advance in technology, improve manufacturing practices to reduce ecological footprints of solar panels. Use renewable energy sources, reducing reliance on fossil fuels for electricity. Closed-loop water systems used during manufacturing reduce water consumptions. Increasingly establishing localized production facilities to reduce emissions of transportations. Next, I will talking about the social and health impacts of energy productions of solar panels. Firstly, I will focusing on land use and landscape. Solar energy systems require less land compared to conventional energy resource. Solar panels can be installed on degraded and unused sites such as deserts, and multi-purpose and integrated use on existing developments such as rooftops. And it have the disadvantages such as it requires high upfront cost of installations. Besides that, it's about the solar energy infrastructure. Solar energy reduces the need for extensive lines and grids to provide energy in decentralized, low density, and off-grid areas. And reduce energy poverty, improving living standards by powering essential services such as lighting, refrigerations, and communications technology. And it has the best size which its requirements for energy storage, such as battery for continuous. And it's created jobs for the society because solar photovoltaic sector is the leading employer in the renewable energy industry, generating millions of jobs globally in manufacturing, installations, and maintenance. Solar energy projects stimulates local economic developments and improving access education by electrifying schools and communities. And it has the bad sides, which when handling the production of solar panels, it can pose a significant risk. Besides that, I will be talking about the negative health risks that poses in the energy production of solar panels due to the use of toxic chemicals and the release of particulate material. The manufacturing of solar panels involves several toxic, flammable, and explosive chemicals. The e-waste found in production of solar panels including leads, brominated flame retardants, and cadmium and chromium. Besides that is accumulate waste. Accumulations of waste from decontaminations or broken solar panels. The lifespan of solar panels is around 25 to 30 years, after which they may need to replace or recycle. And based on the records, by 2050, the waste might yield a value of up to 60 to 75 million tons. It's due to the improper management of waste, it can cause environmental issues. Next, I will be talking about the mitigating climate change. Solar panels reduce the greenhouse gas emissions. Solar panels produce electricity without releasing harmful emissions into the atmosphere. Solar panels reduce the world's carbon footprint. Solar panels decrease the amount of carbon dioxide released into the atmosphere, which leads to global warming and climate change. And finally, but not last, it decreases the environmental pollutions. Solar panels used in photovoltaic technology, where solar radiation is directly converted into electricity. This reduces the air emissions due to the substitutions of electricity and conventional fuels. It do not emit any carbon dioxide gases to prevent greenhouse effects and reduce acid rains.
Next, we will talk about the incorporation of circular economy principle in the solar panel production. Solar panel production aligns with circular economy principle by focusing on waste reduction. Manufacturers innovate to design panels with high recovery value components such as silicon, aluminum frame, and glass. For instance, glass from panel can be recycled into new panel or alternative products like glass form and insulation. Advanced technologies such as laser cutting help reduce waste during the production of silicon wafer and thin film panel. Furthermore, manufacturing byproducts like silicon dust are collected and repurposed to create new wafer. To promote material reuse, manufacturers standardize parts like aluminum frame, making it easier to reuse or renovate them for new panel. Aluminum frames are collected, cleaned, and melted to create new frame or secondary product. Sustainable packaging is also a priority with biodegradable or recyclable material used to minimize environmental impact during transportation and storage. In addition, recycling is essential to ensure that solar panels at the end of their life do not end up in landfill. For example, purified silicon can be reused for new panel production or in other semiconductor industry. Metals such as silver and copper are recovered using chemical separation process, enabling their reuse in new panel or electronic device. Glass, which constitutes about 75% of panel weight, is easy to recycle into new panel or alternative building material. Lastly, solar panels are designed with durability in mind, often lasting 20 to 30 years. Protective coatings such as anti-reflective and starch-resistant layer further enhance their longevity. Modular panel design allows damaged components to be replaced individually without discarding the entire unit, making the panel more sustainable and cost-effective over the time. For the challenge and limitation part, solar panel production faces technological hurdles such as the energy-intensive mining and refining of material like silicon and silver. Current solar cell efficiency, which hover around 20%, means that larger installation may be required. Recycling old panels is also challenging due to the complexity of separating and reusing material. Although solar energy has low long-term costs, the upfront investment in material and technology remain high. Market volatility in the price of silicon, silver, and other essential materials can also lead to unpredictable production costs. Additionally, many manufacturers rely on government subsidy and tax incentives, which may not be guaranteed in long term. For the challenge and limitation part, solar panel production faces technological hurdles such as the energy-intensive mining and refining of material like silicon and silver. Current solar cell efficiency, which hover around 20%, means that larger installation may be required. Recycling old panels is also challenging due to the complexity of separating and reusing material. Although solar energy has low long-term costs, the upfront investment in material and technology remain high. Market volatility in the price of silicon, silver, and other essential materials can also lead to unpredictable production costs. Additionally, many manufacturers rely on government subsidy and tax incentives, which may not be guaranteed in long term.
Okay, opportunity for further improvement in solar panel production. The first one is by technological solution. Development of new materials. We can use perovskite and organic photovoltaic materials for more sustainable, which is less resources intensive alternative to silicon vessel. This is also a potential to enhance energy efficiency and reduce reliance on limited resources. Besides that, energy efficient manufacturing, adoption of cleaner renewable energy power production process to lower carbon footprint. Besides that, we also can recycling technologies, which is advanced recycling method for extracting and reusing material from old panel, reducing waste and resource demand. From economic improvement, the first one is cost reduction strategy, which is scaling up production to achieve economies of scale and lower upfront costs. Public-private partnership, which is we can share risk and fostering investment in solar technology development. Next, supply chain sustainability, diversification of supply chain to reduce geographic dependency on mitigate risk from natural disaster. Next, financial incentive, which is gives us subsidy and international collaboration to promote solar energy project, particularly in developing nation. The last one is for technology transfer, which is facilitating technology and knowledge sharing to bridge the gap between developed and developing nation. Okay, and the next solution is which is we can do from regulatory solution, which is global standard. They need to establish benchmark for sustainable manufacturing and waste management. Okay. For EPR or extended producer responsibility, they need to ensure manufacturer manage the life cycle of their product, including recycling and disposal. Okay, for labor rights and ethical manufacturing, they need to enforce labor laws to ensure safe working condition, equitable pay, and improve worker well-being. Okay, the last one is infrastructure development, building specialized recycling facility and collection system to promote a circular economy. This improvement we can do from environmental sustainability. Okay, the first one is life cycle carbon footprint reduction, which is transitioning production facility to a renewable energy source. Next, energy payback reduction, which is we can using innovative design and material to reduce the time for energy payback, accelerating net positive energy contribution. Okay, the last one is hazardous material management, which is developing safer alternative to hazardous substances like cadmium and lead. Establish a protocol for safe disposal to mitigate environmental risks. Okay, for the conclusion, significance of solar panels. Solar panels are a key component of renewable energy system. They significantly reduce greenhouse gas emission and reliance on fossil fuels, play a pivotal role in global shift towards sustainable energy solution. Okay, the next one is challenge of solar panel production and life cycle. Okay, for the manufacturing challenge, energy, which is energy intensive process and relies on raw material, for example, silicon, silver, indium. Okay, environmental footprint if not managed sustainability. Next, end of life challenge, underdeveloped recycling technology lead to waste accumulation. Economics barrier, high upfront cost, and limited financing option lead to adoption. Okay, for the regulatory hurdles, inconsistent policy across region create uncertainty for investor and manufacturer. Okay, for the solution to overcome the challenge, circular economy principle, which is we can minimize waste by designing panel for recyclability, advanced recycling technology to recover valuable material. Okay, for the technological solution, which is we can use perovskite solar cell for higher efficiency and reduce resource dependency. Okay, energy efficient and cost-effective manufacturing technique. Which, the next solution is collaboration and incentive, which is from financial incentive. You can do a subsidy, tax break, and research funding. The next is public-private partnership to drive innovation, global regulatory framework for consistent investment and deployment. Okay, the next one is the path forward or opportunity for further improvement, which is we can integration of sustainability into every stage of solar panels life cycle. Also, we can do advancement in material manufacturing and recycling to enhance efficiency and accessibility. The last is the collaboration across country to build resilient, sustainable energy infrastructure. At least, vision for the future is solar panel have the potential to transform the global energy landscape. And then, a steadfast commitment to sustainability can combat climate change and reduce environmental degradation. The last is harnessing solar energy is decisive step forward a cleaner, more resilient future. Okay, the last is harnessing solar energy is a decisive step forward a cleaner, more resilient future. Thank you.
Thank you for your attention. I hope our presentations give you valuable insight into the role of solar panel